Good morning, good afternoon, good evening. Welcome everybody to the next special episode of the Ceph cast. Joined once again by Daniel Parks, Technical Product Manager for Ceph. And today we're going to build on what we talked about in the last session and talk more about replication, specifically synchronous replication configuration and two-site replication, with a little bit of a side discussion around Fusion and how this technology is relevant also to Fusion. So Daniel, thanks for joining. You want to maybe just do a quick recap of the last session, and then we'll go ahead and dive right into the next part.
Yeah, thank you, Randy. It's always great being here. Yeah, so as you said, last week or in the other episode, we covered at a high level multi-site replication in general that we had available in Ceph. So we talked about asynchronous replication and how we did that at the service level. So how we did replication for the object storage, for a blog, etc. And we also briefly covered synchronous replication that really brings us RPO 0, and that translates when we're talking about Ceph into a stretch cluster configuration. And today is really what I wanted to dive deep into, with the idea of just initially covering at a very high level the two modes in which we can do a stretch mode synchronous replication, and then dive directly deep into two-site stretch clusters. They are very interesting just because of what you mentioned, that when we are talking about Fusion DR or Metro DR, as it is called, that we want to have replication with RPO 0 inside ODF, inside Fusion Data Foundation, we are actually using this Ceph stretch cluster configuration under the covers. So everything that we explain here is also applies for when you're using Metro DR or replication with RPO 0 in Fusion.
Okay, cool.
So two types of replication that we have available when we are talking about synchronous replication, about stretch clusters. We have the case where the user has 3 sites with very low latency between the 3 sites, and then those 3 sites can have OSDs, can contain data, and can be in the same data path. So all of these 3 sites have low latency between them, and they are also part of the same Ceph cluster. So when we are talking about a stretch cluster in Ceph, we are really stretching a single cluster between our different data centers. Here we have an example of 3 availability zones, 3 data centers in which we are stretching our cluster. Nice things to mention here or to take into account is that it is operated and managed as a single Ceph cluster, so there's no specific configuration per service. This is just a stretch cluster that we are stretching at the OSD level, at the RADOS layer, meaning at the underlying level. So as an operator, I don't really need to worry about each service. All of them are automatically being replicated because the replication happens at a lower level. Here you can see that we have in an image 2 replicas in each site. So really how we achieve the synchronous replication is that if, for example, I use replica 3 or replica 6, what Ceph is going to make sure is that I save. If I'm using replica 6, for example, I'm going to store 2 replicas, 2 copies per data center. So even if I lose a full data center, I'm going to be able to keep providing I/O to the client with the 2 remaining data centers. You could work with 3 copies with replica 3, but we always recommend, and that's what we support and kind of strive for, is with replica 6. Even if the TCO is higher, is clear, for this kind of solution. But the nice thing about having 6 replicas is that you can tolerate a full site failure, so 1 full site is gone, and then you can even tolerate 1 more failure in the 2 remaining sites, like 1 OSD or maybe a full node, and the client is going to continue to have I/O. So in that sense, it really gives you good resilience for the data and durability there, and availability as much as you would expect for this kind of solution. The other option that we have, and that we're going to cover, we're going to go deep dive into it in a moment, is when you only have like two sites that are low latency, dark fiber connected, however we want to call them, that are under 10 milliseconds of the round trip time. That's what we recommend, and we will also cover that in a moment. So you only have two sites, but you still want an RPO zero stretch cluster solution. That's perfectly fine. No? With the two-site stretch mode, what we have is that we have two data sites. We call data sites the ones that actually have OSDs in them. No? So the Ceph nodes that contain OSDs and they are in the data path. So when a client does a read or write, both of these sites are going to be in the data path, and we need to have low latency between them. But what we have here is a tiebreaker site. So we need a third site that is going to be our tiebreaker site that contains a monitor. And this monitor is the one that is going to make sure that we can keep quorum, that everything is going to keep working, even if we lose a site. Important things to notice is that this tiebreaker node, this monitor, is not in the data path. So it can have really high latencies, 100 milliseconds or even higher. It can even be a virtual machine because it's not in the data path. It doesn't need a lot of resources. So I could actually have it running in a cloud provider if I don't have like a physical data center. So this is quite common. We see this a lot, especially in EMEA, that we only have two sites connected together, and then maybe you have a small third site with higher latencies, or you can just use the cloud. We will go into depth in this architecture in a moment. But I just wanted to show you before we go into depth there, again, really make sure that we understand like the networking requirements, because this is key for stretch clusters, that we need like a stable, reliable networks. We really want to avoid latency spikes. So it's very well if you say, okay, I have 1.5 millisecond round trip time during almost all of the day, but then you have 2 or 3 hours at night where it goes to 20, 30 milliseconds. That's going to be problematic for your cluster, because during that period of time, your OSDs are going to be flapping, they go in, out, your client IO is going to suffer the performance. No? So it's important that we have like a reliable network that doesn't have a lot of spikes. As we said, equal latency between the data sites. So the data sites that actually have OSDs need to be under 10 milliseconds round trip time. If you have the two-site stretch configuration, the monitor, the tiebreaker, can be 100 milliseconds or even higher. L3 routing is recommended, so we try to avoid extended VLANs between data centers, because this normally kinds of brings you more issues like single points of failure. So Ceph can be configured with routing, so you can have different subnets in each data center, and Ceph will work perfectly in that way. We would also recommend having quality of service, again, just because what we mentioned before, we really want our Ceph cluster and our clients connecting to our Ceph cluster to have a positive experience. In that sense, it's very important that we can assure inter-site throughput that is always the same. No? So let's say that during the night, we are sure that even if a batch job that is offloading some backup to another site kicks in, that somehow our performance is not going to suffer. No? So we need to have quality of service and have like an assured amount of bandwidth for our cluster. And also it's very, very important when we're doing our kind of math to see the inter-site network connectivity that you need, to take into account that you don't only have to consider your client IO, all of the reads and the writes from your client, you also need to consider when recovery kicks in. So let's imagine that one site goes down for 3 days. Once it comes up again, it needs to copy all of the data to synchronize with all of the data. That synchronization is going to happen in the network, between the sites, and that's going to be extra load on the network. So if we don't cover that, if we don't add it into our calculations of the inter-site throughput, it can also affect the client experience. That is always trying to.
So it sounds like, excuse me, site preparation and configuration preparation for this. You mentioned 1 week here. We want to have very robust consistent testing over a long period of time to make sure we can flatten out any of those spikes and make sure that all those in-band activities don't disrupt the data flow, right?
Yes, yeah. One thing that is really easy is having some kind of easy script that you like a ping or something maybe a little bit more advanced, but where you have kind of an average. But in the end, you can leave it running for a week, a couple of weeks, and then you can see if you have kind of spikes, no? And it's an easy way to check. So we always recommend to leave it running for a while, because sometimes we have some clients that maybe do 12 hours, and then you're missing maybe some hours where something kicks in and is really heavy on the network. No, so an easy way of making sure that you don't have those spikes is you leave it 1 week, 2 weeks running, and then you go back, check the data, check the latency during, and then the average latency, and maybe even the P99 if you want to be a little bit more sure of it, and then you can just be sure that you don't have any of these issues going on.
Yeah, makes sense. Okay.
Okay, so moving forward, the other thing that I wanted to mention, and this is the last one before we go into the two-site kind of configuration, and I show you a little bit from the CLI and a demo that I have for you, is understanding why the inter-site networking latency is so important and why do we mention it so many times. So let's imagine in this example that I have here in this diagram that I have configured replica 3. So it means that I want to store 3 copies of my data, and each copy is going to go to a different site, in this case, to a different OSD. So this primary OSD is going to be one site, secondary another site, etc. No? So this is a workflow that we have in Ceph when a client is doing a write. No? So let's say that the client does a write to the primary OSD. That's one round trip time, let's say. So that's 1.5 milliseconds he has written here. And then is the primary OSD is the one that is going to take care to copy the data to the other OSD. So he still needs to make 2 more copies to the secondary and the tertiary OSDs. These writes happen in parallel, so we don't have to wait for one to finish to go to the other. If we have 3 copies, 4 copies, 5 copies, they all happen in parallel, no? But even then, you need to take into account that we need to do the write and then get the acknowledgement back. So that's 3 milliseconds. And then finally, once the data, all of the copies have been written in all of the disks in the different sites, then the primary OSD is actually going to confirm to the client and give him the acknowledgement that that IO that he has written has succeeded. So as you can see, we favor consistency here. This is what brings us RPO 0. So we're completely sure that this is synchronous, but it also brings with it that if we have high latencies between the sites, each of these jumps is going to be more painful and is going to add to the total latency for each IO that the client is going to have. No? So this is why I always like to show this slide, just so it's clear why we insist so much on having low round trip time between the sites to have a good experience regarding IO and the performance that the client is going to get.
Makes sense. Okay.
And finally, just some of the advantages that we have already talked about stretch clusters. They have simple day 2 operations in the sense that you don't need any special configuration. Everything works more or less in the same way. You can actually complement it with multi-site asynchronous replication. So you could have your stretch cluster in a small and in different data centers, but you still want to have geographically dispersed data replication. You can configure a stretch cluster and then do asynchronous replication to a different geo if that's a requirement, for example. You can sustain an entire site failure plus 1 node failure in the remaining sites while maintaining client IO traffic. You can sustain double site failure without data loss. This is if we talk about 3 availability zones of 3 data centers. If you lose 2 data centers, even if the client can write with that single data center, once the data is still there, still available, we have an available copy. So once the sites go back, he's going to be able to recover and we haven't lost any data. No, this is when we are talking about the 3 data center configuration. And also the nice thing that we will see in a moment is that you don't need any manual intervention when we have to fail over or fail back or recover a site. It just happens automatically for us without any administrator intervention. And for disadvantages, just to mention that the networking side of things is very important for performance, for the availability of the data. Also to take into account that this is like a kind of expensive solution. We want to have RPO 0. We want to be sure we don't lose any data. Replica 6 for 3 sites is what we recommend, and replica 4 for 2 sites. So as you can imagine, the total raw capacity overhead is quite big, with a solution like this. But again, you want to be sure that your data is safe, and you want to have synchronous replication, RPO 0. So that goes into the cost. And then one thing that we can't forget compared to a synchronous replication is that here we are working with a single cluster. So even if it's very nice to work with a single cluster when you're talking about operations and doing upgrades, etc., because it makes our life easier, we also need to take into account that if we have some kind of corruption in the software, some issue software-wise, it's going to affect our cluster, and everything is a single cluster, so that's also a thing to take into account when we're working with the stretch clusters.